So far we have discussed about three different types of I/O interfacing, I/O techniques. Uh, you have a simple I/O, a pooled I/O, interrupt-based I/O, and fourthly you have DMA, or what is known as direct memory access. So it's a fast mode of data transfer between the memory and some other external ports. Fine. Fast data transfer between memory and some external ports. We can have different types of programmable memories like PROM, EPROM, EEPROM. So using the DMA, we can be able to transfer data between the memory and the external devices. So direct memory access is basically a process of data transfer, and it is controlled, or it is actually initiated by the external device. Initiated by external devices. So just like interrupts, it is the external device, the external peripherals, IOs, that will be responsible for initiation of the data transfer. So where it is used, it's actually used where basically the microprocessor uh, control data transfer is slow. We go for direct memory access because direct memory access usually is a much faster method of using this data transfer. And we can have, say for example, we are transferring data between uh, floppy and the memory of the system. That will be actually DMA. So directly transferring the data between external device and the memory of the microprocessor. There are actually two pins that we know, pin number 38 and 39, hold and HLDA. So these two pins are actually used in the direct memory access. So what happens in this case is so what does the hold pin do? We have somewhat discussed this earlier also. So uh, it's a simple pin that's actually high active high state. It's actually high active in the high state, and it is an input signal to the 8085 microprocessor. Whatever out external device is actually requesting, uh, maybe the use of address and data buses of the microprocessor, hold will be activated. Fine. So after basically receiving the request from the external device regarding the use of address and data bus, the microprocessor will transfers the address bus and the data bus to the external device in the next machine cycle. So as soon as the current machine cycle is over, in the next machine cycle, the data bus and the address bus are now relinquished to the microprocessor, to the external device for use. Active high input to the input to 8085. It's an input pin, so externally initiated. For relinquishing the data and address bus of 8085 to the peripheral, the external peripheral. So whatever the peripheral device is, that basically request the use of address and data bus for initiating data transfer. So once this basically request is processed, the buses will be tri-stated. All these buses, the data bus, the control bus, the address bus, they are tri-stated, and HLDA signal, that's another pin that we are using in the microprocessor. Hold signal is actually sent out. So only after the hold becomes low again, the microprocessor will be again able to take control of the buses. So the buses are let to the use of the peripheral device as soon as hold is set. Fine. So as soon as the signal is set, and this is your hold, and HLDS simply acknowledges the relinquishing of buses to the control of peripheral devices. So in this case, the processing does not take place through the microprocessor. The external device directly accesses the memory by taking over the control of the data bus and the address bus. So only after this signal becomes low again, the microprocessor will be able to take control back of these two buses. So this takes place in the so hold is actually acknowledged as soon as the request is basically made. The hold is actually acknowledged in the next machine cycle. This figure here basically shows the use of DMA or data transfer. What we see in this case is normally DMA controller is used for initiating the request with the microprocessor for use of the hold for for sending the request to the hold through the hold pin, and then taking care of the control of the buses so that direct communication can be made with the memory. So you can see actually address bus of the microprocessor as well as the data bus of the microprocessor is directly under the control of this DMA controller. So Intel basically uses this DMA controller for interfacing the external memory with the microprocessor, with the memory of the microprocessor, not with the microprocessor. And this DMA controller, it's 8257, and so 8257 DMA controller. Let's make it basically makes use of the memory and of the microprocessor by taking over its address bus, data bus, and control bus, and helps in whatever memory is, whatever the peripheral device is actually trying to take care of the memory. Right? So direct communication is actually avoided between the peripheral and the memory. This communication is made through a controller. That pin is 8257 DMA controller, and only after the hold signal becomes low again will the DMA controller release the address bus, the data bus, and the control bus to the for use of by the microprocessor. So this is all about I/O techniques. This was the last I/O technique that we had to discuss, and we need to now discuss about interfacing of various devices with the microprocessor 8085, and we also have to study counters and how we can program counters using microprocessor. So that we'll be doing in the next session.